Alright, we're going to take a look at Unit 13, which is metric dimensions. Back when I was a kid, I remember whenever they said, man, everything's going to the metric system. By a certain date, we'll be completely metric, all millimeters. You won't see anything to do with the English system of measurement anymore. Well, here we are, 2012, and we still have stuff hanging around that's in the English system of measurement here in the U.S. In 1975, the U.S. Metric Conversion Act was signed into law. Industry has slowly adapted the metric system. We do have a lot of stuff to deal with the metric system now. When you go into an automotive industry, all of your cap screws, all of your fasteners, everything to do with that vehicle is going to be metric. One reason why they wanted to go to the metric system was because they wanted everything to be interchangeable. They thought we needed to be having everything interchangeable because we wanted to be globally competitive with foreign markets. And that is true. Now, you might say, well, why are all our prints we've read up to this date in inches? Well, the thing is, if you're a tool maker, a machinist, a maintenance person here in the U.S., you're still going to be using inch micrometers. You're still going to be using inch dial calipers. Very rarely will you see somebody with metric measurement tools. With that being the case, that means that we're still going to be measuring in inches. We really don't want to work with prints that are in millimeters if we're using inch measurement tools. That'd be an awful lot of problems translating over, and we'd probably make a lot of mistakes if we had to sit there and do it that way. So what did I do whenever I worked at Premium Allied Tool? We got a lot of metric prints in because the majority of the work that we did was from overseas. The very first thing a person would do whenever that print would come into the factory, someone would convert it from metric to inches, and we would make what we would call a print for the PAT print. We always called the metric print the customer print. That customer print stayed on file, and anytime we sent something to our customer, it always had to go back as the customer print. You didn't send it back to them with it converted over to inches or anything like that. The converted print was just for our internal use. The most important thing we're going to learn on this lesson today, first of all, what are the two systems of measurements that we use? We use the English system of measurement, which is right here in your book. The United Kingdom and the United States, most use that. And then we use the International System of Units, or System International. That is the metric system. Okay, that's what we go by, and it is in millimeters. Now, if I look down here, the most important thing for you to realize is how do I convert from inches to millimeters or from millimeters to inches. If you look right here, 1 inch equals 25.4 millimeters. Okay, if I see 1 inch equals 25.4 millimeters, that means I can take whatever I have in inches and multiply it times 25.4, it gives me millimeters. Again, this is written down out there in your unit. I've actually got this written where you can take and look at it, but inches times 25.4 gives you millimeters. So if I had a print that was said the part was 2 inches long, okay, I could take 2 inches times 25.4, that's going to tell me that it is 50.8 millimeters. Okay, so that's how I can convert from inches to millimeters. If I want to convert from millimeters to inches, I just divide by 25.4. I take my millimeters, divide by 25.4, it gives me inches. For instance, I take the 50.8 millimeters, divide it by 25.4, it tells me that the part is 2 inches long. So by those two formulas, I can take and convert from millimeters to inches and inches to millimeters. I remember the 25.4. Now, here's the thing. A millimeter is 0.03937, It's 39 thousandths, 3/10, almost 4/10 in a millimeter. Okay? If we took millimeters and multiplied times that, it's going to give us our inches. Don't try to remember this number. Okay? Don't try to remember that number. It's just something. And I'll be honest with you, I don't know why this says 397 or say 394 right there, and that should say 394 because it's 3937, not 397. But that's what is in an inch. That's how many thousandths are in a millimeter. So just scratch those numbers out and don't try to remember them. They're on there. It is a conversion factor. You can use it. It's not a terminating decimal. It goes on forever. It just keeps on going. If you look on a calculator, it just keeps on going. 25.4 is a terminating decimal. Use it because it's exact. We either multiply times inches to give you millimeters, or we take 25.4, we divide into millimeters, and it will give you inches. Okay? So those are the two that we're going to use. Millimeters divided by 25.4 equals inches. Inches times 25.4 gives you millimeters. You need to be able to do this on an exam. We will be converting numbers. Now, we're going to get down and we're going to talk about prints. I've got a metric print right here. This metric print, I can't look at all of it. You won't be able to see the numbers all at once. But if you look in the title block, it says metric. Okay? That means every number on here is metric. Look where it was made. This print was done in Scotland. Okay? Not Glasgow, Kentucky. Glasgow, Scotland. Okay? We need to take a look at this. And what I want you to first look at first angle projection. That means it was done overseas. Our right side view is actually supposed to be our left side view, right? Because we're looking through the part. See the little part sticking out here? It's actually on this other side over here. So this is actually your left side view if you're over here using third angle projection. We've already talked about that, but we hadn't really looked at a lot of prints to do with that. But this is a first angle projection print. Everything on here is in millimeters. You look here, you see 33 plus or minus 0.01. Or no, that's plus or minus 0.1, I'm sorry. You've got a leading zero on metric numbers, 0.1. So on and so forth. You have tolerances on metric prints just like you do anything else. I'm looking to see if there's a general tolerance block on here. Yes, and there is. It's plus or minus 0.4. So there is your tolerance block on this print. Now, what would I do if I was going to have to make this part? First thing I would do, I would come in, I would convert every number on here to inches. How do I do that? I look right here, I say 33 divided by 25.4, it tells me how long that is in inches. I write it on the print. I could take 0.1 divided by 25.4, that's going to tell me what my tolerance is. I go around and convert every number on here and I write it on my print. That's the first thing I would do is convert my print. Now we also have prints sometimes that are dual dimensioned. Right here's a print that's dual dimensioned. And I apologize that it's turned up sideways, but it's dual dimension. If you look right here, it's got inches over millimeters. That's what our title block's telling me. There's inches over millimeters. 1 inch, 25.4. Okay, 1.75, 44.5 millimeters. You've got one here, 2.500 plus or minus 1,000th. And that is 3.5 plus or minus 0.02. Okay, so 0.02 is equivalent to 1,000th. This is a dual dimension print. You see these kind of prints out there. There's some out there. Now, your book, when you look at it on page 75, gives you a print, and it's got a chart up in the corner that tells you what each dimension on there is equal to in millimeters. That's not very realistic, and you don't run into that very often. Most of the time you're going to see a print like this, or it's either going to be metric or inches. You won't usually see a table up in the corner of the print that's got all the equivalent dimensions on it. Not saying you won't ever, but it's not very likely. I haven't dealt with any other than what's in this book. Now, the only other thing I want to point out to you for D12, make sure you know on question number 12, and it will be changed in your actual ones that I've got typed out and you do the part on the computer. It says surface I in question 12. It should say surface 1. The only other thing on question 8, it says what does surface A represent? Tell me what it actually represents. What feature on the part does it represent? Because there's not another letter or number or anything like that that it's referring to. If you have any questions, let me know.